Dear children, in this presentation I would like to teach you the first lesson of the topic composition of a mixture. To cover the whole competency level, you need to follow 2 more videos. As you know, the composition of a mixture is not a constant as the composition of elements in a chemical compound. According to the requirement, we can change the composition of mixtures. As an example, we can change the composition of fertilizer according to the type of crop and according to the stage of the crop or the requirements of the land. If consider the manufacture of the cement, the manufacturer is always very much keen on the composition of the prepared cement. Why? If the composition changes, that affects the quality of cement. In other words, it is necessary to maintain the composition of mixtures to get the expected result. In day-to-day life, we come across with many different homogeneous mixtures such as salt solution, vinegar, sugar solution, eau de cologne, rubber latex, other types of gums, liquid polishers, scents, shampoo, brass, the air we inhale, etc. It is very much essential to have a correct composition in some mixtures practically. As example, composition of a saline water. It is very much need to prepare the correct composition of the saline water. Otherwise, it will affect the patient's conditions. Other than that, when preparing weedicides, pharmaceuticals, and in laboratory works, and in hydroponic farming, the preparation of the solution or the preparation of the mixture is very much important. Let's do the activity 3.21 to get a clear idea about this. Take 50 milliliters of water into 2 equal beakers and add 0.2 grams and 0.4 grams into the beakers, 0.2 grams into beaker B and 0.4 grams into beaker A. Now, just looking at the 2 beakers, you can say that the compositions of the 2 beakers, the solutions in the 2 beakers are very much different, just looking at the color. Beaker A gives you darker color, beaker B is less dark. So that gives a rough idea that the solutions in the 2 beakers are not equal. Because here the 2 solvents contains the water. Water is the solvent. Here those 2 solvents are equal. But you add 2 different masses to each of the beaker so that the unit volume contains more solutes in A than B. Therefore, we can say the composition of the 2 solutions are different. But there must be a correct way to express the composition. We cannot just say, looking at the color, or we cannot say these 2, the compositions are different. There must be a correct method to express the composition accurately. Now let's see how we can express the composition of mixtures. We can express the composition as a mass fraction. It gives the ratio of the mass of the solute to the total mass of the mixture. Here you have to measure the mass of the solute and the total mass of the solution. Both are given in either grams or kilograms or whatever in the same So you can say mass fraction is a fraction, so do not have any unit. By multiplying this mass fraction into 100, you can get weight percentage. Now let's see the worked example here. 200 grams of solution contains 10 grams of a solute. Give the composition of the solutes of this mixture as a mass fraction. First thing, when you get this kind of problem, the first thing is you have to write the formula. Then substitute the given data here. Mass fraction of the solute is equal to the mass of the solute divided by the total mass of solution. Here the solute is given in 10 grams and the mass of the solution is given as 200 grams. So 10 grams divided by 200 grams, you will get 1/20. The gram and this gram and gram are cancelled off. So it is 0.05. No units because it is a fraction. This is another example. A particular mixture of brass contains 120 grams of copper and 30 grams of zinc. State the mass fraction of copper and zinc. So here you have to give two answers. First thing, you have to find the total mass of the mixture. Copper 120 and zinc 30. Together it is 150 grams. So mass of copper as a fraction, mass of copper divided by the total mass of mixture, that is 120 divided by 150, that is 0.8. By multiplying with 100, you will get the weight percentage. It is as 80%. Likewise, the mass fraction of zinc also calculated as the same manner. Third one, saline solutions, sodium chloride aqueous solutions are often used in medicine. What is the weight percent of sodium chloride in a solution now? 4.6 grams of sodium chloride in 500 grams of water. So here it is said aqueous solution. That means sodium chloride 500 grams and water 4.6 grams. So the total gram is 504.6 grams. So this is the sodium chloride mass fraction as this way. Here are some more problems. Try to do this. If you want, you can solve many examples given in your textbook. Now you learn one way of expressing the composition. To learn the other ways of expressing composition, you have to watch the next two videos. This is a small attempt to help you in this tragic situation. So subscribe my channel, and if you think this is helpful, please share it as much as you can. Thank you.